Okay, here we have a schematic of a series circuit. We have resistors 1, 2, and 3 represented by these symbols.
This is the negative terminal and the positive terminal, as well as an ammeter wired in series and a voltmeter wired in parallel.
Okay, so here we have our series circuit. We have two batteries supplying voltage to the circuit. From the positive terminal, the current flows through the first resistor. Then the current flows through the second resistor. Then we have an ammeter wired in series through which the current flows. The current then flows through our light bulb back to the negative terminal. For this circuit, we have an external switch. So when I turn the switch, the light bulb goes on.
Okay. The net resistance in a series circuit is equal to the sum of all the individual resistances. So if R1 is 10 ohms, R2 is 16 ohms, and R3 is 52 ohms, the net resistance is 10 plus 16 plus 52 ohms, which is 78 ohms.
Current is the same at all points in a series circuit. So in this circuit, we've measured the current at two spots. The current's represented by I1 and I2. So if I1 is equal to 2 amps, then I2 is also equal to 2 amps. Okay, so for this problem, we're given a schematic of a series circuit with 3 resistors, and we're asked to find the value of the second resistor. From Ohm's law, we know that the total voltage is equal to the total current times the net resistance. The diagram gives us the value for the total voltage, which is 9.0 volts. We're also given the value of the total current for the circuit, which is 0.50 amperes. Using Ohm's law, we can solve for the net resistance, which equals 18 ohms. Knowing that in a series circuit, the total resistance is equal to the sum of the individual resistances, and plugging it in the given resistance values. So the value of the first resistor is 10 ohms, and the value for the third resistor is 3.0 ohms. So then solving for the value of the second resistor, we get 5 ohms.
Here we have a wired parallel circuit with 2 resistors wired in parallel and a light bulb to indicate whether the circuit is on or off. The current has the option of either traveling through the resistor or through the path of least resistance through the yellow wires and then to the light bulb.
Okay, so for this problem, we're given a schematic of a parallel circuit with resistors R1 and R2 hooked up in parallel. We're given the value for the net voltage and net current, and we're asked to find the value of R1. We start off by using the Ohm's law equation, V net equals I net R net. After plugging in our known values and solving for R net, we get R net equals 3 ohms. Knowing this is a parallel circuit and how resistors behave in parallel, we can set up our equation of 1 over R net equals 1 over R1 plus 1 over R2. After plugging in the values for R net and R2, we can solve for R1, which we get as 3.6 ohms.